All right, integrals 2, day number 2, definite integrals and integral techniques combined. Boy, that kid looks like he's got a bonus question on the test thanks to Morgan Henderson Photography. That's probably some copyright issue there. Let's get started. Your integral investigation lab, I want you to find the integral of all of these. That looks like fun. That kid wouldn't be smiling anymore. So determine the following indefinite integrals. Find relationships and patterns wherever possible. Write 3 bullet points at the end to describe math relationships discovered during this process. Fun. Split it into 2 pages apparently. Do some work. Have fun with it. There's your rubric for that. Hey, let's see how you're doing. Why don't you give these a try, see what methods you think apply. So actually, you know what? Take a moment and just kind of write down thoughts on how you would do each of these. Don't do them, just write down a thought and then come back to the video. Alright, so here I would use some form of the integral of 1 over a squared, square root of a squared minus x squared dx, which is equal to, as we recall, the arc sine of x over a plus c. Let's see if we can put that in that form. I'm going to bring that 5 out in front. I would leave this as 1 over. And it looks like a pretty simple 3 squared minus x squared dx. So it looks like a equals 3. Therefore, I'm fairly certain that we'll carry this 5 along with, and we get the arc sine of x over a plus c. What the heck? Put an a there. What's a? A is 3 plus c. Sweet. Okay, I'm seeing an arc tangent here in the second part. Let me get rid of some of this. Give myself some space. That's bothering some of you, I know. Maybe I'll leave just a little bit to bother you. Right there. Yep, that's going to bother a bunch of you. Alright, that's good. We got to keep you... Yeah, okay, so anyways, the integral of 1 over a squared plus x squared dx is going to equal 1 over a times the arctangent of x over a plus c. I'm sorry, this is bothering me just as much as it's bothering you over here. Oh no, I can't get rid of it. Oh, great. So if I can get this into that form, we should be good to go. So let's do this. Let's factor out 4. Okay, so that would be 1 over 9/4 plus x squared dx. Alright, which would be the same as 1/4 the integral of 1 over 3/2 squared plus x squared. Now I've got a equals 3/2. So recall, I would have this 1/4 times 1 over a. 1 over a would not be 3/2, it would be 2/3. Times the arctangent of x over 3/2, which would be 2x over 3, plus c. Let's simplify. That would be 1 over 6 arctangent of 2x over 3 plus c. There we go. It looks like we got in our first example of a definite integral. We have limits of integration right here and here. Okay, so let's just assume there's going to be a u sub problem, which it's not, but let's just go for it. Oh, dx. Oh, yes. What kind of problem is this? It's called change the variable. X equals u plus 5. Okay, so I have the integral from 7 to 10 of x, which is u plus 5, times u to the 1/2 power du. So that would be the integral from 7 to 10 of u to the 3/2 power plus 5u to the 1/2 du. So integrate. That would be u to the 5/2 times 2/5 plus 5 times, now we're going to come over that in a second, 2/3, there we go, plus, we don't need a c here. Yes, we don't need a c. Why? Because it's a definite integral. So since u was equal to x minus 5 to the 5/2, we're going to do a direct substitution. That'd be 10/3 x minus 5 to the 3/2. Let's go from 7 to 10. I'm going to do this off camera. Oh man, is this going to get filthy. Boy, oh boy. This is going to be 2/5 of 5 to the 5/2. So 5 to the 5th, square root of that, plus 10/3. Boy, I don't even know if I want to do this. This would be the square root of 5 to the 3rd, which is 125, minus 2/5. The square root of 32, that's 2 to the 5th, plus 10/3. That'd be a square root of 8. Gross. Okay, you guys, I'm not going any further with that because I don't really care. But notice that I had upper limit, lower limit. When I plugged them in, then I took their difference, fundamental theorem of calculus. So let's get on to today's lesson. Okay, so basically what you're going to do here is you're going to be using methods of integration that we've used so far. So here, I mean, I see it right now, it's going to be u sub. Here, u sub. Here, boy, that's actually going to be u sub as well. And here, u sub as well. So here I would call u x cubed plus 1. Here I would call u x squared plus 16. Here I would call u, 2 minus x squared. And here I would call u natural log of x. And I'm going to focus in on part f here. So if u is natural log of x, then du is 1 over x dx. Okay, so du takes care of this, and here is u. So this would be the integral from 1 to 2 of u du. Well, that would be u squared over 2. Okay, but u squared over 2 isn't, we're not going to input 1 and 2 into that. We're going to input 1 and 2 into the natural log of x, quantity squared, over 2. And we're going to input 1 and 2. So let's see what we get. Alright, so if I evaluate, I would get the natural log of 2 squared minus the natural log of 1 squared. The natural log of 2 squared is going to be the natural log, the natural log of 2 squared. And this is going to be 0. Therefore, this would be the evaluated integral from 1 to 2 of natural log of x over x dx. Let's try a couple more. Let's see which ones look the ugliest. Let's see here. U substitution here where u is sine x. U substitution here where u is cosine x. What? You're saying what? Well, this is just sine x over cosine x. Okay, here I do u substitution again, where u would be cosine x. And here I would do a u substitution where u would be sine x. Okay, recall though that cotangent of x is cosine x over sine x. Okay, so I want to focus in on this one real quick. So if u equals cosine x, then du equals negative sine x dx. Almost a perfect match. Let's make that negative du equals sine x dx. So negative du 1 over square root of u. Right? The sine x dx taken care of by du. So that would be the same as the integral from 0 to pi over 3 of u to the negative 1/2 du. Okay, so that would be negative u, oh, hold on now, to the 1/2 times 2. So u again at the start was cosine x, and that's going to be the square root of cosine x, right? So let's evaluate that from 0 to pi over 3. So that'd be negative 2 square root of cosine of pi over 3 minus negative 2 square root of the cosine of 0. Okay, pay attention to that negative there. So that's negative 2 square root of cosine of pi over 3 is, what is this? Cosine of pi over 3 is 1 over root 2. Okay, that is gross. Minus, oh no, that's wrong. 1/2, let's try 1/2, I like that better. Plus, right, minus a negative. 2 times the cosine is, square root of cosine is 0. Square root of the cosine of 0 is the square root of 1. So that's negative 2 times the square root of 1 over 2 plus 2. We can do more with that. That's negative 2 times 1 over root 2 plus 2, which I would just leave. So the integral from 0 to pi over 3 of, what was this thing? Sine x over the square root of cosine x dx is equal to, I would take out a 2 and call this 1 minus 1 over root 2. Boom shock. Now any form, this form actually would probably be acceptable, or this, or even this, or in that case, that'd probably be the most desirable right there. Okay, all right, that is lesson, what is that, lesson 3? Yeah, lesson 3 on definite integrals and these methods of integration.